dividing polynomials, long division advanced. All right. So I have a basic video, an intro to long division of polynomials, and the deal is it has to be in descending order, and all the terms have to be there, starting with the highest power down to a constant. And in the basic video, I only have that scenario. I don't have anything out of order, don't have anything missing, and in this video, that's the deal. So when performing long division of polynomials, everything needs to be in descending order, and all powers of the variable must be accounted for from the largest down to no variable at all. All right? This video will address those issues precisely when polynomials are not in descending order and or there are missing powers. I will also throw in an example of a higher order denominator for good measure. Division of polynomials can get as wild and crazy as it wishes or as your teacher wants to get, okay? But the techniques discussed in this video can handle anything it wants to throw at you. Again, for an introduction to long division, watch my video Dividing Polynomials Long Division Basics. The other thing I do is I start with dividing whole numbers, which is something you're very familiar with, and relate it to this method. All right, so negative 8x plus x squared minus 9 divided by x minus 3. So with what we just talked about, this is not in descending order, right? So I want to change this to be x squared first. Right, I know my negative's in front, but my negative goes with my 8x. My x squared is positive, so we put nothing in front of it when we write it first. It's understood. And then the minus 9, still there, minus 9. And then over x minus 3. So now this is in descending order, and all the powers, right, x squared, x, and then no x at all, are all accounted for, and they're in the correct order. So now I'm ready to come down here and say, okay, x squared minus 8x minus 9's in my house here, and then out front is x minus 3, and then start my process of long division. So now this is going to work just like the basic. There's nothing missing here, but it was out of order. That's the advanced part here. It was out of order. So we had to put it in order. Now that we do this, it's going to be what we know to do already. So remember, I look at x and x squared. I say, what do I multiply by x to get x squared? Well, that's going to be x. And then I distribute to both those things. So x times x is x squared. That's why I did it. If I don't get something identical right here, I messed up. Start over. And then x times negative 3 is negative 3x. And then what do? I change my signs. I subtract. Minus here, plus here, that cancels. If that doesn't cancel, again, you messed up. Start over. And then I say, okay, negative 8x plus 3x is negative 5x. And then I bring down my minus 9. All right, and if you've seen me do any of these or heard me do any of these, then I'm at my bring down step. And when I'm at my bring down step, I start over again, right? So I look at x and negative 5x this time. What do I multiply by x to get negative 5x? That's correct, negative 5. So negative 5 times x is negative 5x. And again, those are identical. That's why I did it. Then I also multiply this by this negative 3 here. I got to distribute it. Negative 5 times negative 3 is plus 15. And after I multiply, I change my signs, right? I subtract. Minus, that becomes a plus, and this plus becomes a minus. That cancels. Again, the first column has to cancel. More can cancel, but not less. It has to be at least the first column. Negative 9 minus 15 is negative 24, and that is our remainder. So how do I write this? Well, this is going to equal x minus 5. And then if it's a one-term remainder, recall, I can bring this negative sign in front of it and then have this fraction here where I say 24 over what I divided by, which in this case is x minus 3. So 24 over what I divided by, x minus 3. The other way you could write this, I'm going to box this in. The other way you could write this is x minus 5 plus negative 24 over x minus 3. And you would definitely want to do this if it was more than one term. On this one, we won't have more than one term as a remainder, but it could happen as you do long division. So again, 9x plus 18 minus 11x squared plus 12x cubed over 4x plus 3. This is just not in descending order, but all the powers, 3, 2, 1, and then no x, they're all there. So I just need to rewrite this in descending order. So 12x to the third minus 11x squared plus 9x plus 18 all over 4x plus 3. So under my house is going to be the 12x cubed one. And And so you'll notice, just like a fraction line, just like my fraction line needs to extend fully, my house needs to extend fully. That way I don't have any ambiguity on what's outside, what's inside, where's this at, where's that at. It's all there. All right. Again, that's those details that I say. All right. 3 things that make you better at everything in life: paying attention to detail, being a problem solver, not a problem creator, and being efficient. You learn those things from math. You might not ever do this long division until your 9th grader comes to you and says, I need help with this in algebra. All right. But if you can problem solve, be efficient, pay attention to detail, you'll be a better, you fill in the blank or whatever you do for life. Okay. So 4x and 12x cubed, what do you need to multiply by 4x to get 12x cubed? Well, 4 times 3, and then I have 1x here, and I need 3, so I need 2 more x's, so I need x squared, okay? And the reason I write it here is because there's my x squared column, okay? Everything with x squared goes there. That way I don't get confused and write an x squared here, because I can't have 2 x squareds in a row, and this is my x column, so I can't do that, all right? So 3x squared, and then I multiply 3x squared times 4x. And look, this better happen. That's the whole reason I picked that, was so that I get the same thing, so it cancels when I change my signs. Then 3x times positive 3x squared is going to be plus 9x squared. And then I just mentioned it, I changed my signs. Make this a minus, make this a minus, that cancels. And negative 11x squared minus 9x squared, they're both negatives. You don't subtract, you add them together and keep it negative. That's why I told you earlier, minus sign doesn't mean subtract. It means change the sign and combine like terms. Well, I'm changing the sign of that 9 to make it negative, and so then a negative 11 and negative 9 is a negative 20, and then x squared. When you add like terms, you get a like term. Bring down your plus 9x, and then I'm ready to start the process over again. I look at 4x and negative 20x squared. What do I multiply by 4 to get negative 20? Negative 5, and then I have an x. I need 2 x's, so I need 1 more. That fits perfectly with my x's there. So negative 5x times 4x is negative 20x squared. Negative 5x times positive 3 is negative 15x. And then guess what I do? That's right, change my signs. I always change my signs after I multiply. Change signs. Make that a plus, make that a plus. That cancels, right? Negative 20x squared plus 20x squared cancels. And 9x plus 15x is... You add it and keep it, right? 24, keep it positive. 24x, and we bring down what? Plus 18. Now I'm ready to do my process one more time, right? Every time I change the yellow here, I'm doing the process again. I look at 4x and 24x. What do I multiply by 4 to get 24? 6. What kind? Positive. Do I need any x's? No, I have one. I needed one. I don't need any more. So 6 times 4x is 24x, and then 6 times 3 is plus what? 18. And then I do what? Change my signs. Minus here, that cancels. This actually also cancels, so that my remainder in this one is what? 0. So then my answer is simply this. There's no remainder to write. So I just have 3x squared minus 5x plus 6. And just to mention it in this video as well, I can take this and multiply it by what's in the bottom or the denominator, and I better get this, right? So I know that's a little bit bigger than FOIL to multiply. It's 3 terms times 2 terms, but you can multiply it and then combine your like terms, and you should end up with what's there, right? Because the opposite of division is multiplication. All right, so let's go on to the next one. Here we go. This is in descending order, but I have x to the third, and I'm missing what? I have x and I have a number. I don't have x squared. Oh boy, what do I do now? Well, let's just look and see what we do. So I have x to the third. I have minus x, and you'll notice I left some space there, and then x minus 1. The reason is I don't have x squared. I've got to have a place for it. It's got to be a placeholder. So I'm going to come down here and say, okay, for x squared, I've got to have something there. So I'm going to have plus 0x squared. So that has no value, but think about the number. Like if I had the number 1023, that's the hundreds column. There are no hundreds here, right? There's 1 in the thousands, a 2 in the tens, a 3 in the ones. But with a number, we have to write that. If I didn't write that 0, then that would be a different number, right? 123. So with numbers, it's automatically there, right? You have your placeholders. But with polynomials, it's understood there are no x squared, so we just don't write it. There's 0 of them. Right? If we don't have one, don't write one. So That's why you have to have something there, and if you don't, you'll mess up your columns, right? I need an x to the third column, an x squared, and an x, right? I need those columns there to keep things lined up and that sort of thing. So now, let's go through here and figure out what's going on here. I need to multiply what by x to get x to the third? Well, I don't want any coefficient, but I need an x squared, and now, right off the bat, I need this column here. X squared times x gives me what? X to the third, and then x squared times -1 is negative x squared, and then I changed my signs, got to change them signs. Minus, plus, that cancels. And I'm left with 0x squared plus x squared, which is just good old x squared, right? 0 doesn't change whatever is right here. That just comes down. And then we bring down our what? Minus x. And I'm ready to start the process over again. What do I multiply by x to get x squared? Just good old x. What kind of x? Plus x. So x times x is what? X squared, that's why I did it. X times -1 is negative x. Is that right? And then what? Don't forget to change them signs. Minus here, plus here. That cancels, and wait a minute. Did I do this right? Let's look at it. That's x squared, and that's minus x. That's what I have here. So guess what? This cancels too, and I'm left with nothing right here, right? I'm left with nothing. I bring down my 1 plus 1. I'm still just left with 1. Can I multiply x by anything to get nothing here? Really, I can put 0x there if I want to emphasize there's no x's. But there's nothing there, right? So if there's nothing there, there's nothing. I would like to go here to finish, but I can't. There's nothing to multiply by, so I'm done dividing. How do I write my answer? Sometimes you get a 0 here. Well, don't write the 0. It's just nothing there. So when I get ready to write this, it's going to be what? X squared plus x, and then there's nothing here, but I need to add or subtract my remainder. Well, my remainder is what? 1. So then I have plus 1 over, what did I divide by? I divided by x minus 1. That's also the thing out front. That's what you always put in the bottom, the denominator of your remainder. All right? So I'm just going to look at this one more time, make sure there's nothing that goes here, right? All right. How could we check one with a remainder, by the way? We could take this and multiply it by this, and then in the end add the remainder, okay? We could multiply those things together and then get a remainder. Add or subtract the remainder in the end. So if we wanted to, we could say x squared plus x times x minus 1, and that's going to give us x to the third minus x squared plus x squared minus x. So those cancel, and we get x cubed minus 1, but then we have to add the 1, so plus 1. I'm sorry, minus x. I don't know if that went away or I didn't write it. So is that what I have right here? Yep, sure is. So go ahead and erase that, but that's how you could check it. We multiplied it first, simplified it, and then we added that remainder in the end, and it ended up being what we started with in the numerator. All right, so then what's the deal with this one? Not only is it not in descending order, but it also is missing something. It has x cubed, it has x squared, but then it has no x's. So let's rewrite this as 2x to the third plus 7x squared minus 11 over x plus 2. So when I come down here in my house to do this, I have the 2x to the third. I have the plus 7x squared. I'm going to leave space for my x's and then minus 11, and then x plus 2. So this is going to be plus 0x. So that's just, again, that's just a placeholder for my column for my x's. And then, I don't know why I went with that color, I need a new one. So here, x and 2x cubed, I need a what? A 2x squared. So that's going to go here, 2x squared. I multiply that by x and get what? The whole reason I did it, right? 2x cubed. And then 2x squared times 2 is plus 4x squared. And then what do I do? That's right, change those signs. Change those signs, right? Minus here, make this a minus. That cancels. That doesn't cancel. We made a boo-boo, start over. Put a Band-Aid on it, start over, right? Plus 7x squared minus 4x squared is 3x squared, and we bring down my placeholder of plus 0x. It has no value. It doesn't, but it's just a placeholder saying here's my column for my x's. And now I start the process over again. What times x is 3x squared? Well, it's going to be plus 3x. 3x times x, right, is 3x squared. That's why I did it. And then what do I do next? I do 3x times plus 2. Even though there's nothing there, I still have to put this down. Plus 6x. And then, you guessed it, change those signs. Got to change them signs, all right? Right here, minus. Make this a minus. That cancels. And I'm left with 0x minus 6x is negative 6x. And I bring down my negative 11. And then, go to the blue one more time. One more time through the process to try to fill this in here, right? And because I have an x left here, I can multiply x by that and get what? X times negative 6. So negative 6 times x gives me the whole reason I chose negative 6, negative 6x. Negative 6 times positive 2 is negative 12. And then I do what? Change those signs, right? Plus, plus, that cancels. Negative 11 plus 12 is 1, and 1 is my remainder. So how do I write that final answer? Okay, I have this. I have 2x squared plus 3x minus 6 plus 1 over, what did I divide by? X plus 2. So 2x squared plus 3x minus 6 plus 1 over x plus 2. So this one, x to the fifth plus 2x squared plus 7 over x plus 1. This is actually missing multiple exponents here, right? So let's see here. It's going to be, it's already in descending order. So when I do my, I'm going to come up here and give myself plenty of space because this is x to the fifth. This one might take a while, right? X to the fifth. I'm missing an x to the fourth and an x to the third. So plus 2x squared. Then I'm missing x and then plus 7. I got all kind of stuff missing. So let me come back in here and put what's missing in here. We're going to put plus 0x to the fourth, plus 0x to the third, plus 0x. Okay? So now we have 5, 4, 3, 2, 1, right? In order, descending order, and even my missing stuff is now accounted for. And then out front I have what? X plus 1. And then I look at this and go, okay, what do I multiply by x to get x to the fifth? That will be x to the fourth. So x to the fourth, and then I multiply and get what? X to the fifth plus x to the fourth. And then what do I do? Change those signs, right? Change those signs. Make this a minus, make this a minus, that cancels, and I'm left with what? Negative x to the fourth, and then I bring down my plus 0x to the third. Again, just a placeholder, but it's important. Then I say, what do I multiply by x to get negative x to the fourth? That will be a negative x to the third. Then when I multiply, I get negative x to the fourth. And then I multiply times the 1 here, and I get what? Negative x to the third. And then what do I do? Change the signs. Change those signs. It's going to be plus and plus. That cancels out. If it doesn't, you messed up. And then I end up with 0 plus 1 is going to be x to the third, and bring down my what? Plus 2x squared. And I'm ready to start the process over again, right? Got several more times through the process here. What times x gives me x to the third? X squared, and it's positive. So multiply that by x, I get plus x to the third, or x to the third. And then x squared times 1 is plus x squared. And guess what I do? Change those signs. Right? Minus here, make this a minus. That cancels, and I'm left with, what am I left with? X squared, right? And I bring down my plus 0x, and I'm ready to start the process over again. Good gracious, this one's long because it's x to the fifth, isn't it? That's why we don't do many x to the fifths with long division. X into x squared is what? X plus x. And then we say x times x is x squared. X times 1 is plus x. And then what do? That's right, change those signs. Change those signs. Make this a minus. Make this one a minus. Cancels. 0x x minus x is negative x. And then I bring down my what? Plus 7. Holy cow. All right, finally. And then I say, what do I multiply by x to get negative x? Negative 1. Negative 1 times x. Wait a minute. Negative 1 times x is negative x. That's why I did it. And then negative 1 times 1 is what? Negative 1. And then I do what? Change those signs. Plus, plus, that cancels. 7 plus 1 is 8. And that 8 is my remainder. So now I have all of this, and then my remainder is positive, so it's going to be plus. So let's try all that down. It's going to be x to the 4th minus x to the 3rd plus x to the square, x to the 2nd plus x minus 1 plus 8 over what I divided by is x plus 1. So the numbers didn't get too crazy and big there, but that was just a lot of stuff, right? That long division of x to the 5th is big time, okay? But I wanted to show you missing several powers there, okay? I can honestly say in well over 2 decades of teaching this and a decade before that of tutoring this, I don't know that I've ever seen a teacher give this on a test or on homework. This is a pretty long problem. But again, I wanted to drive home the point of these can be crazy and wild if they want to be. They can get a lot worse than this, unfortunately, for all of us. So here, x to the 4th plus x cubed plus 5x squared plus 5x. Wait a minute, that's in descending order. Nothing's missing. But look down here. X squared, it's in descending order, but there's no x. So guess what? Even that has to have everything a placeholder. Okay, so I wanted to throw one of these in there with good measure, and not only did I throw one in there, but I threw one in there, it was a special case with missing that x. I say special case, it's the same idea, all right? Same idea here. So let's look through this one here. Let's start with this. Let's say that this is going to be x to the, you know what, I probably should have that up a little higher again because this is x to the 4th. Still going to be a pretty big problem. Plus x to the 3rd plus 5x squared plus 5x plus 4 all over x squared plus 3. And notice I left space there. Why did I leave space? Because I need to put plus 0x in here. Plus 0x. Need a placeholder. So I need to say, what do I multiply by x squared to get x to the 4th? Well, x squared. So x squared times x squared is what? X to the 4th. X squared times 0x is plus 0x to the 3rd. That's important. It's 0. You still write it just so that you have a place in the placeholder. And then plus 3x squared. Plus 3x squared. And then change those signs. Change those signs. Minus, make this a minus, which doesn't matter, 0, make that a minus. That cancels, and I'm left with, what am I left with? A positive x to the 3rd, and then 5x squared minus 3x squared is plus 2x squared, and then we bring down the plus 5x. And again, you really only bring down the number of terms that cancels out. So like here, one term canceled out, only bring down one term over here is kind of how that works. All right, no matter how big these get. So then I look at this and go, what do I multiply by x squared to get x cubed? Just good old x. So plus x. Then I multiply x times x and get, or x times x squared and get what? X to the 3rd. X times 0x is 0x squared. And then x times 3 is plus 3x. Plus 3x. And then, wait a minute. And then I change my signs. Always changing them signs, right? If you subtract, you're subtracting all 3 terms. Change a minus, minus, and minus. That cancels. And that leaves me with 2x squared plus 2x, and then bring down the plus 4. And then I look back at this and go, okay, what do I multiply by x squared to get 2x squared? And I realize that I didn't line stuff up correctly. So y'all been screaming at the computer this whole time, I'm sure. Let me fix this. Look what this column is. Oops. Look what this column is. Those are my x cubed columns, right? I wrote that in the wrong place. I wrote that in the wrong place. So let me fix that. This x should be over here in my x column. This plus sign should be here in front of it. This x squared should be in the x squared column, right? Thank y'all. Y'all finally yelled at the computer loud enough I heard you. Okay? I'm human too, see? So, but rather than re-record this whole video, I'm going to just move that over, right? So now everything should be in order. You can quit yelling at the screen now, right? Now my x squareds are in order, my x's are in order, and I got confused to myself. I said, look, I'm about to be done with this thing, and I was still going to write something over here, and I was like, wait a minute, these things aren't in order. So, right, make that mistake, go fix it. Catch those things, all right? So 2x squared and x squared is what? It's going to be 2 plus 2. So then 2 times x squared is 2x squared. And then 2 times 0x is plus 0x. And then 2 times 3 is going to be 6. So plus 6. And then I change those signs, right? Change those signs. Minus here, minus here, minus here. That cancels. And I'm left with 2x. I'm left with, let's see. I want to just get another color in here because I like this color. 2x and then minus 2. 2x and then minus 2. So now how do I write this? Well, I have x squared plus x plus 2. And then I'm going to put plus because I have a 2-term remainder. So I don't want to try to get into moving the negative out or anything like that here. I'm going to have 2x minus 2 over x squared plus 3. Now, if you wanted to factor a 2 out of that, you could and say this is 2 times x minus 1. All right, but that's not going to divide out down here. So then I think that's okay. In this case, we're just going to leave this here. Leave this in this scenario, and then I can write the or down here. We could have written x squared plus x plus 2 plus 2. But we typically, I mean, unless it divides out, we're going to leave that remainder sort of like it is there because you're not going to do much else with it. All right. So forgive me for lining up my stuff wrong here earlier, but now it is right in the end, which is good. I would not want to have finished this and had it in the wrong place, but there's my x squareds. Here's all my x's, and then here's my constants, right? And remember, as I got close to finished, I thought, oh, something's not right because it's not finishing up correctly. And then I realized, oh, my goodness, I didn't line up my powers correctly, my terms. So there's my remainder, 2x minus 2, and I chose to factor it here. So I would probably take either answer. Again, because this doesn't factor and they're not the same as y there, but it's never a bad thing to have this factored if you want to, okay? Unless your teacher tells you not to, and then don't do it for sure.